32 bits, we can have 2 power 32 possible combinations from all zeros to all ones. It means there are 2 power 32 possible IP addresses. And we have seen that in all these IP addresses, if we use the same fixed number of bits to address the network and the remaining bits to address the host within the network, then we could not support different size networks. Also, it led to very bad utilization of the address space. Thus, in order to support different size networks and in order to have a comparatively better utilization of address space, classful IP addressing was introduced. Here also we use fixed number of bits to address the network, but here we divide the entire set of IP addresses into classes. With 32 bits, we have a total address space of 2 power 32 possible IP addresses. Among them, half the number of IP addresses begin with 0 and another half begin with 1. All those IP addresses which begin with 0 are kept under class A. And among the IP addresses which begin with 1, half of them begin with 10 and another half begin with 11. All those IP addresses which begin with 10 are kept under class B. And among the IP addresses which begin with 11, half of them begin with 110 and another half begin with 111. All those IP addresses which begin with 110 are kept under class C. And among the IP addresses which begin with 111, those IP addresses which begin with 1110 are kept under class D and those which begin with 1111 are kept under class E. This way, we divided the entire set of IP addresses into 5 classes. Class A consists of all IP addresses beginning with 0. Class B consists of all IP addresses beginning with 10. Class C always begins with 110. Class D begins with 1110 and Class E begins with 1111. And we can say that class A occupies about 50% of the total address space. With 32 bits, there are 2 power 32 possible combination, which is equal to 2 power 2 into 2 power 30, which is equal to 4G or 4 billion IP addresses. And in class A, the first bit is fixed to be 0. Remaining there are 31 bits. With 31 bits, we can have 2 power 31 possible combination. 2 power 31 is equal to 2 into 2 power 30, which is equal to 2G or 2 billion IP addresses belong to class A. It means 50% of the total address space belong to class A. And in class B, the first 2 bits are fixed. The remaining 30 bits, with remaining 30 bits, we can have 2 power 30 possible combination. 2 power 30 is equal to 1G or 1 billion. Hence, class B occupies 25% of the total address space. And class C occupies 12.5% of the total address space. Class D and E occupies 6.1% of the address space respectively. So based on these leading bits, we divided the entire set of IP addresses into classes. And why are we dividing them into classes? In order to support different size networks. For that, in all the IP addresses belonging to class A, in all the IP addresses beginning with 0, the first octet or the first 8 bits is reserved as network ID and the remaining 3 octets are reserved as host ID. Thus, in all the IP addresses belonging to class A, the first 8 bits are used to address the network and the remaining 24 bits are used to address the hosts within the network. And in class B, it's different. In class B, the first 2 octets are used as network ID and the last 2 octets are used as host ID. So in class B, the first 2 octets are used to address the network and the remaining 2 octets are used to address the host within the network. And in class C again it's different. First 3 octets are used to address the network and the last octet is used to address the host within the network. Thus, we can see that class A address less number of networks, but all are large networks. It means class A is reserved for large networks or large organizations. And in class C, we can address large number of networks, but all networks are small. It means class C is reserved for small networks or small organizations. And class B is in between these two, and hence it's reserved for medium networks or medium-sized organizations. Finally, class D is used for multicasting and class E is used for experimental purposes. So based on the leading bits, we divided the entire set of IP addresses into classes. Within each class, we are using the same fixed number of bits for network ID, but for each class it's different. As a result, we are able to support different size networks. We can support large networks, small networks, and medium-sized network. As a result, we can have a comparatively better utilization of address space. For example, for a small network, we can supply the network address from belonging to class C. As a result, the wastage of addresses can be avoided.